Let's take a look at the next lesson, which is called Explaining Steps for Rewriting Equations. And our goal here is, again, to take a look at some of the algebraic moves that create equivalent expressions or equations, and to describe how equivalent equations are related to the steps of solving equations. So first off, let's take a look at solution here. And 7.1 talks about, is 0 a solution to each equation? Explain your thinking. All right, so if we're going to explain if 0 is a solution, then we're going to need to put it in for the value of x, and if it makes the statement true, then it is a solution. If it doesn't make the statement true, then it's not a solution. So let's take a look at the first one. If we put 0 in for x, we get 4 times 0 plus 2 equals 10, which would be the same as 4 times 2 equals 10. So I guess the question mark here would be, does that work? Does 8 equal 10? No. Putting 0 in for x makes the equation false, or does not make the equation true. All right, let's try it for another equation. So let's go across here. So if I put in 0 for x in this one, let's see, I have 12 minus 8 times 0 equals 3 times 0 plus 4. And once again, let's see what happens here. Is this true? All right, so that would be 12. 8 times 0 is 0, so 12 minus 0. And then this would be 4. 0 plus 4 is 4. And so 12 equals 12. So yes. Yes. Substituting 0 in for x, the equation is true. 12 does equal 12. All right, let's put it in for x in the third one down the bottom left here. So that would be, is 5 times 0 equal to 1/2 times 0? Is that true? All right, well, 5 times 0 is 0, and 1/2 times 0 is 0. So yes. Substituting 0 in for x makes the equation true. All right, so then we have the last one here is 6 divided by 0 plus 1 equal to 8. All right, so this is one of the commandments of math that I have up in my room, is thou shalt not divide by 0. All right, that is undefined. We cannot divide by 0, so no. Okay. Substituting 0 in for x makes the equation false. All right, you cannot divide by 0. Try it. Type that in your calculator. 6 divided by 0. You cannot divide 6 into 0 parts. So it will not work. It will say undefined, and so that would be a false statement, and so not a solution. So the solutions that end up working out, so 0 is a solution for the top right and the bottom left. All right, so in class, we might take a look at this a little bit more in depth with the Desmos activity, but we're going to move on. If you haven't done that Desmos activity, or if you were not in class, that might be worth taking a look at. 7.3, it doesn't work. Noah is having trouble solving two equations. In each case, he took steps that he thought were acceptable, but ended up with statements that are clearly not true. Analyze Noah's work on each equation and the moves he made. Test to see if the solution is correct. If not, where in the process of solving the equation did Noah go wrong? Circle the mistake, then correctly solve the equation if necessary. All right. so let's go ahead and take a look at the steps that we have here. So when we are going through the equation, we have all of these steps, and notice that the reason for the steps have been listed over on the right, or just stating what the step was in words as we try to get x by itself. And in the first problem, we end up with x is equal to negative 15. All right, so let's take a look to see if that is a correct solution. So to know if it is correct, let's put it back in. Let's substitute it back in for x in the equation. So negative 2 times negative 15.5 minus 5, does that equal 21? So this would be negative 2, negative 15.5 minus 5 is negative 20.5. Does that equal 21? Looks like probably not here, because negative 2 times negative 20.5 will be positive 41. Does 41 equal 21? No. So that is not a solution. So let's go back up and see if we can figure out where the mistake was made here. All right, so first step when you're solving this, looks like they did the distributive property. So let's check that out. So distributive property, negative 2 times x would be negative 2x, and negative 2 times negative 5. Oh, wait, there's the mistake, right? This right here, negative 2 times x, but then negative 2 times a minus 5 should be a positive 10. You can either think of it as negative 2 times negative 5 is positive 10, or negative 2 times 5, you'd be subtracting a negative, which would turn into a plus sign. So the mistake happened right there in the equation. And so let's go bring that down here and see if we can fix that mistake. So it should be negative 2x plus 10 equals 21. All right, so let's go ahead and solve that then. So subtracting 10 from both sides to undo the addition. We get negative 2x equals 11. And then dividing by negative 2 to undo the multiplication, we end up with x is equal to negative 5.5. So the solution is negative 5.5. And if you really want to double check that, now you can plug that back into the equation and see that it does work. Negative 2 times negative 5.5 minus 5 does equal 21. All right, let's go down to the next one. All right, so once again, we have an equation with a series of steps, all algebraic operations, and we'll see if those were the correct algebraic operations. But since we have a solution here, let's go back and see if that's a correct solution. So we got to plug that back in for x everywhere we see it in the original equation and see if that works. So it is 2 times negative 2 plus 7. Does that equal 4 times negative 2 plus 1 minus 3 times negative 2? So we got that in there a number of times, so I'm just going to highlight it. So we had these three places we were putting that x value back in. So it ended up here and here and here. All right, let's see if that works. So gotta now kind of do our PEMDAS, our order of operations. So 2 times negative 2 would be negative 4, so negative 4 plus 7. All right, so 4 times negative 2 is negative 8, so negative 8 plus 1. And then negative 3 times negative 2, or minus negative 2, would be plus 6. Okay, so that ends up as 3 equals negative 8 plus 1 plus 6 would be negative 1. So again, this is a question mark here. Is this true? No. Okay, so negative 2 is not a solution. Let's go through the steps and figure out, all right, where did we go wrong here? All right, so combining like terms here. Right here it says combine like terms. So notice we have some like terms here and here. 4x plus a negative 3x, or 4x minus 3x. We can combine those together, and that is a 1x, so that looks good. 2x plus 7. All right, that looks good there. All right, and it looks like the next step we're trying to subtract x from both sides of the equation so we can get the x's together on the same side of the equation. So we're going to subtract x over here, and subtract x on the left side. So we're subtracting x from both sides. So on the right side, all right, the x's cancel each other out, so you get left with 1. And on the left side, let's see, 2x minus x. Oh, there's the mistake, right? 2x plus negative x, or 2x minus x, would be a 1x here, a 1x. So that is where our mistake is. So let's circle that. Right here is our mistake. And let's take that down and actually figure out what that should be. So kind of like I did back up in the previous problem. Let's bring that down here. So we said that that actually should be, instead of 3x, looking at these like terms, we should have a positive 1x, or just x plus 7 equals 1. Okay, so that's a pretty quick one to solve then. Once we have that, right, we'll subtract 7 from both sides, and we get x is equal to negative 6. So this should be our solution. We plug that back in. 2 times negative 6 plus 7 should be equal to 4 times negative 6 plus 1 minus 3 times negative 6. All right, so that would be our correct solution. We can plug it back in to see if that is true, and that should work. Okay, number 3. All right, let's change to purple here. All right, so once again, we have a series of algebraic steps here to see. Right, these are steps that you would do to solve an equation. And let's see if what we've got here. So we have this, x equals negative 2. Let's check the solution. So let's plug that back in everywhere we see the x. So 2 times 5 plus negative 2 minus 3, does that equal 3 times negative 2 plus 9? So I'm going to highlight again what we did there. We're taking that negative 2 and we're putting it in every place we see the x. So those two places, so here and here. And then we're trying to see, is this true? All right, so let's just be careful here. So 5 plus negative 2 would be 3, so that ends up as 2 times 3 minus 3. 3 times negative 2 is negative 6, so negative 6 plus 9. All right, let's keep simplifying that. Is that true? Well, let's see. 6 minus 3, is that equal to negative 6 plus 9? Looks like this one actually is going to work. 6 minus 3 is 3, negative 6 plus 9 is 3, so yes. X equals negative 2 is the solution. All right, so no mistakes that we have to circle on that one, no correct work, because all of the work that was done in this problem, combining like terms and then going through and subtracting from both sides, we have gone through all the correct algebraic steps. X equals negative 2 is the solution. All right, so this is our lesson for today. Just understanding how to verify a solution is a solution, and then going through and seeing if you can identify where a mistake may have been made in the algebraic steps to find that solution. If you'd like to go on and try some of the Are You Ready for More problems, feel free to do that. If you're feeling really confident and want a little extension, a little bit of a puzzle to solve here, then that would be good. Otherwise, that will end our work